Hi there. In this episode, we are going to talk about inverse variation functions. So, inverse variation, what in the world does that mean? Well, that means as one thing varies, the other thing is going to kind of be going in the opposite direction. So, our general equation here will be f of x equals 1 over x. Because what this means is as y increases, x is doing the opposite of that. Or as x increases, y is getting smaller, really. They are inversely related. Another way to write this, just so you know, another way to write this would be f of x equals x to the negative first power. Because anytime you have a variable in the denominator, to jump the bar, you can switch the sign. And that is good to know because this is also a power function. So inverse variation can also be a power function. Well, there's also f of x equals 1 over x to the nth power, where n could be 2 or 3 or 4 or 5. And you could rewrite that as f of x equals x to the negative nth power. Okay. A or 1 doesn't have to be a 1. This could be an A. It could be any number. And then you'd put an A here or an A here. Now, if you have an odd exponent, so this one, your graphs, I guess I should put that in the graph section. So if you have an odd exponent, your graph is going to look something like this. You're going to have a piece of it over here, and you're going to have a piece of it over here. And if A was negative, then these would flip. They would be here instead. If you have an even exponent, then it's going to look something like this. What you'll notice is that regardless of whether it is even or odd, you have an asymptote right here, which means there are no y-intercepts. You will also notice that you have an asymptote right here, and it doesn't matter if it's even or if it's odd. So let's talk about the domain and range here for a second. Well, the domain for this one is going to be all values except for 0. So negative infinity to 0, union 0 to infinity. This says that our domain is this interval here, but it can't be 0, and this interval here, but it can't be 0. Our range is exactly the same thing. It's going to be negative infinity to 0, and then 0 up to infinity. The domain for this one is the same thing because you have x values all the way through here and all the way through here, but your range is different. Your range is it can't be 0 or anything below, so you'd say 0 to infinity. So there's our domain and our range for this particular set of examples. So what are some features that we notice about these functions? Well, there is a variable in the denominator or a negative exponent. So there's a variable in the denominator or a negative exponent. See variable in the denominator or negative exponent. Variable in denominator or negative exponent. So that's the first feature. There are no x or y intercepts. The domain is not all real numbers, and neither is the range. So you really have to analyze what's going on. Now, these inverse variation functions, they are applicable in real life, but normally when we're looking at them, we'd only be looking at this first quadrant. So we will see inverse variation come up in life situations, but normally we'll just look at the first quadrant. So what I challenge you to do now is I challenge you to go to Desmos and just play around with these graphs. Just figure out what happens when you change A or B. There's no B here. So we've got f of x equals, and let's say we have A over x to the power of B. I'm going to add a slider here. So what these sliders do is they start changing our number. So right now we have A is 1 and B is 1. So really this would be 1 over x. But let's say I want B to be 2. Look at what happens. And that's what we talked about in those features or those graphs, is now I have an odd x or an even exponent, and so they're going in the same direction. Let's move it to 3. It's flipped back this way. Let's move it to 4. There we go. What happens if A changes? Oh, it makes it further away from the y-axis. It flips it into the negative direction. All sorts of things. So this is what I challenge you to do. I want you to go onto Desmos and play around with these functions.